Hi, my name's Tom Saxa and I'm a mentor for First Robotics Team 997 here in Corvallis, Oregon. You know, the students have been talking about how some teams will occasionally show up at a competition with a robot that's not quite fully debugged and asking what we could do as a team to help them out with some things to come better prepared. One of the things our team uses is a variety of electrical demonstrators to teach the various components of the robot to the new students, and also testers that help exercise those parts so that you could also use these to take control of the various portions of your robot and help in the debug process. And we're going to build one today. The simplest one is a device that will control the spike controller. The spike is probably the simplest device, control device that you will have on a robot, and the tester that controls it is equally simple. I could demonstrate it here. We've got a board with a spike and a small motor on it. I'm going to take my spike controller, plug it into that device, and now I've taken control. I can run the motor in forward and in reverse and use this to verify that this portion of my robot is working properly. So we're going to build that today. It should be relatively easy to do, and we'll move over and take a look at the parts you're going to need to actually construct this. Okay, the parts we're going to need for our tester are a 9-volt battery and a 9-volt battery clip, either a brand new one or one that you've pulled out of an old radio or something, doesn't really matter. 2 momentary push button switches. These are the kind that are spring-loaded buttons at one end and have 2 connections on the other end, though it's really good to get the ones with only 2 connections. That way you don't have to worry about where the wires go. You can't wire it incorrectly. We're going to use a PWM cable, and we use the name PWM cable for these things, but they carry a lot of kinds of signals other than PWM cables, and in the case of the spike controller, it's not a PWM signal that's going to it. So remember that. And we only use the male end. So if you have one of these that's damaged, cut off the male end and you'll have a cable to use here. We're going to use a resistor. I'm using a 1K ohm resistor to make sure that I have enough current to turn on the spike, but not too much to damage it. And this resistor, if you can't find that exact value, it's not a critical component. You can use 1.5, up to about 2K ohms, and as low as maybe 500 ohms, and it should still work fine and not have any problems. We'll need a couple small pieces of wire to wire this together, and then a project box to put it all in. I always like to use plastic project boxes. I think it gives the project a more finished look, but the students like to use little Altoid tins, which will work fine as long as you're a little careful with where the wires go through to make sure they don't get shorted out or stripped on any of the sharp edges. That's all we need. Let's move over to the soldering station and actually start putting this together. Okay, I've got my safety glasses on. Let's go ahead and start to construct this tester. I've already got 3 holes in the little project box I'm going to use here. 1 for the wire at one end and 2 for the 2 switches at the other end. And I'm just going to run the wire into the box, put a small knot in it so that I can hot glue that in place later on when the tester's together. And that's the first step. Okay, the next step, we're going to take our a piece of heat shrink tubing and put it over this black wire from the battery clip and connect that to the black wire in our PWM cable. We're going to twist it together and solder it. And if you don't have heat shrink tubing, don't worry, just run some electrical tape over it instead. So if you're using electrical tape over it now. If not, Go ahead and move the heat shrink in place, and then shrink it down over your connection. Okay, for the next step, I want to take the positive or red lead of my battery clip and connect it to a resistor, and then connect that to the connection I just made on those two switches. To make that easier to do, I'm going to add a small piece of wire to this whole thing. So cut off a small piece of wire, and then take your resistor and wrap it to one end to the battery clip, the red positive connection of the battery clip, and that small piece of wire you cut off, connect that to the other end, cut those to length. We're going to add a little bit of solder to this whole thing to solder those connections together. Notice that I'm getting a nice mechanical joint before I do the soldering. That helps the soldering work a lot better. And then we will take a small piece of heat shrink or electrical tape to run over these connectors and insulate them. And after I go ahead and shrink that in place, that completes that step. Okay, as I mentioned, we just have that resistor between these two pieces of wire, and this piece of wire we want to connect to the same connections on the switch that the piece we already wired the two switches together with is connected to. Doesn't matter which end, just go ahead and wrap that one well onto that connection. Go ahead and add a little solder, and be careful not to get the switch too hot, because if you're using some cheap switches with a lot of plastic, it might start to come apart if you get it too hot. But you've got to get enough solder on there to at least hold it together. Okay, at this point you should have two connections on each of the switches that don't connect to anything, and two connections on your PWM wire, a red and a white. So we want to go ahead and just take each of those pieces of wire and run them to one of the switches. That's just about our last step. Go ahead and twist those on nicely so they stay in place. Add a little solder, and that should be all of our electrical connections. All we need to do is put the case together, and we're almost done. Okay, now that we've got this electrically connected, we should probably wrap just a little bit of electrical tape around those connections to make sure that they don't short out, since we're using a metal box. We don't want anything touching and creating a short on us. So we'll go ahead and wrap a couple pieces of electrical tape around the connections, and then we'll just slide the switches through the pre-drilled holes. And we should be able to put a small nut on each of them to hold them in place. Okay, so we're done. All we need to do is put our battery onto the battery clip and throw it in the case. You could add a small piece of foam rubber to keep that from rattling around inside, and we're ready to test it. The white end goes to the W side of the spike, and we should be able to run it in forward, run it in reverse. What do you know, it works. That's a simple tester you could build yourself with a few inexpensive parts for testing a spike controller. This is Tom Saxa again from First Robotics Team 997 in Corvallis, Oregon, reminding you of that old Yankee saying, use it up, wear it out, make it do or do without. We'll see you next time.